Hi guys, welcome to my channel. In this video we are going to solve a question about the engineering hydrology, and the question will be from the chapter of hydrograph analysis. And so now let's solve the question. But before we solve the question, if you like these videos, if you want to see more of the videos, please subscribe and share with your friends. So now let's pass the question. Let's read the question, what it asks to us. So cumulative rainfall depths of a certain storm over a basin and the ordinates of the S-curve obtained from unit hydrograph for 2 hours of this basin are given below. Total direct runoff depth for this storm is found as 60 millimeter. Okay, so direct runoff is 60 millimeter. Determine the Hyetograph and the phi-index equation of surface flow hydrograph in terms of unit hydrographs and the lag times. Ordinates of the storm hydrograph, assuming a constant base flow of 10 meter cubic per second and the area of the basin. So now let's start with the first one, okay? The Hyetograph and the phi-index. So let's write it here. And this is time. This is 0. This is 6. This is 9. And this is 12, right? So the cumulative rainfall, this is going to be 60, sorry, this is 0, and this is 60, this is 75, this is 120. And now I'm going to write the delta D. Between the 0 and 60 is 60, and between the 75 and 60 is 15. And between 100 and 120 and 75 is 45. And now let's write the delta T, the time differences. Sorry, this is hour. Yes, this is hour. It's going to be delta T. And between the 6 and 0 is 6. Okay, and between the 9 and the 6 is 3. And between the 12 and 9 is 3. So now we are going to determine the intensity. Intensity is going to be 60 over 6 is 10, 15 over 3 is 5, and 45 over 3 is 15. So now we got the intensity. Let's draw the Hyetograph, and we are going to determine the phi-index. So for Hyetograph, we are going to need 2 axes. And for example, this is 6. This is 9, and this is 12, and this is 0. And between this 0 and 6 is 10, right? So for example, this is 10. And between the 6 and 9 is 5. Look at here. So this is going to be, for example, 5. And between the 9 and 12 is 15. This is hour, right? This is time. So now this is the Hyetograph of this storm. So now let's determine the phi-index. Phi-index. Okay. So let's assume that phi-index is any place here, okay? And this distance is equal to x, and this is equal to phi-index. But let's read the question. If you remember that, it says that direct runoff depth for this storm is 60 millimeter. So what does it mean? The area is above phi-index is 60 millimeter, okay? 60 millimeter. So we are going to make an assumption. For example, if it is at 5. If it is at 5, okay? If it is at 5. So until that point, okay, this is phi-index, if we assume. So it's going to be 10 minus 5 multiplied 6. And this area, it's going to be 30, right? It's going to be 30. And this area, 15 minus 5, 10 multiplied 3. This is going to be 30. And 30 plus 30 and 60. So that means that our assumption is correct. The phi-index at 5. But if we assume that it is greater than 5, so how we're going to write an equation? I'm going to show you how to write an equation, because the way of equation is better than everything. 15 minus x multiplied 3 right? 15 minus x multiplied 3 plus 10 multiplied x multiplied 6. So I'm just going to use dot multiplied 6 equal to 60. This area, this both area, because now we don't know. For this one, I don't make any assumption. I just say that maybe it's greater than x. Okay, so it's going to be 45 minus 3x plus 60 minus 6x and equal to 60. Okay, when I take this to this side, it's going to be 0, and when I take this both x's to here, it's going to be 45 equal to 9x, and x is equal to 5. Okay, now we obtain the phi index as 5. So now the first part is okay. So let's solve the second part. For the second part, the equation of surface flow, hydrograph in terms of unit hydrographs and the lag time. So let's do it. For this one, for surface flow, which water as acts for the surface flow? Here, right? This area. This area. So now let's draw it here. I'm going to draw for you. For example, this one. This is 6. This is 9. And this is 12. This is 0. And this 10 minus 5, 5. 5 along to 6, right? 5 along to 6. So, and here is 0 because this is infiltration. Okay, this is infiltration. So this one, 15 minus 5 is 10. So it's going to be, for example, 10 here. And this is going to be 10. As 10 here, okay? So now we got the water that act as the surface runoff. So now let's write the equation. SH equal to 3 multiplied unit hydrograph for 6 hours. Why 3? This is 5 millimeter, okay? This is millimeter. 5 multiplied 6 is 30. 30 millimeter. 30 millimeter is equal to 3 centimeter. And this 3 is for that, okay? So now, plus 9 hours lagged. 9 hours lagged. 3 multiplied. Why 3? Let's check. Look at here. This is 3 multiplied 10, 30 millimeter, and 30 millimeter is equal to 3 centimeter, okay? 3 multiplied this one. So this is going to be unit hydrograph for 3 hours, okay? Now the formulation is this one. We got the equation of the part B, okay? The part B is also solved. And it says that the ordinates of the storm hydrograph, assuming a constant base flow of 10 meter cubic per second, and area of the basin and the fourth part. So we are going to use this one for now, okay? I take the data to here, and for this one, it asks, look at here, it asks to determine this unit hydrograph for this one, okay? To determine this one. So how we are going to determine? The first, I need to determine the unit hydrograph for 6 and unit hydrograph for 3, and then we are going to take the summation of them. So now let's do it. The first, I'm going to start with the unit hydrograph for 3, okay? For this one. So if it is 3, I need the unit hydrograph 3, okay? Listen here carefully. I need to lag for 3 hours, okay? If it asks unit hydrograph for 3, I need to lag for 3 hours. So 1, 2, and 3, okay? I'm going to start with the fourth one. So this is going to start with here, and this is going to be 0, and 3, 12, 30, and 45, and 57, 66, and this is going to be 72, and this is going to be 75, right? And I can take it here as 75 because it's also the same. So now this is going to be 3 hour lagged 3-hour lagged, unit hydrograph 2, okay, unit hydrograph 2. So now this is 3-hour lagged, unit hydrograph 2, and I'm going to take the differences, differences, this both, okay, the difference. So it's going to be 0, this is going to be 3, this is going to be 12, this is going to be 30, this is going to be 42, this is going to be 45, okay, and this is going to be 36 and 27 and 18 and 9 and 3 and 0. Now we got the differences, but we are to obtain the unit hydrograph for 3, we have to multiply the differences with a ratio. So what is the ratio? Look at here. The ratio is going to be the given hour is, look at here, is unit hydrograph for 2 over which one is asked, unit hydrograph 3, okay, 2 over 3. I'm going to multiply these differences with 2 over 3, okay. So let's multiply it. This is going to be 0, this is going to be 2, 8, so 12, multiply 2 over 3, 12 over 3, 4 multiplied 2, 8, okay. So this is going to be 8. So let's do it for here, 20 and 42, 28, and 30 is 45 is 30, and this is 24, this is 18, 12, 6, and 2 and 0. Now we obtain the unit hydrograph for 3 hours, so let's do it for the 6 hours, and then we are going to take the summation of them. So for 6 hours, again, I'm going to use the same S-curve, unit hydrograph 2, okay. So, but now I'm going to obtain unit hydrograph for 6 hours, right? For 6 hours. So how it's going to be? I am going to lag 6 hours. So this is going to be lagged as 6 hours. 1, 2, 3, 4, 5, 6. Okay, I'm going to start with this one. 0, 3, 12, 30, and 45, and 57, okay, and 66, 72, 75, and 75. So now let's write it here. This is 6 hours lagged unit hydrograph 2, okay, 6 hours lagged. So now here is going to be 0 minus 0. So this is 0, okay. It's going to be differences. So 3 minus 0, 3, 12 minus 0, 12, 30 minus 0, 30, and 45 minus 0, 45, and 57 minus 0, 57, and this is 66, and this is going to be 69, and this is 69, but this is 63, and this is 45, this is 30, and this is going to be 75, this is going to be 75, 75. You can write it until the last column. It's okay, because this all will be 75, because there is no any measurements here as a difference, okay? There is no any different measurement here. So, and 75 minus 57 is 18, and this is 9, this is 3, and this is 0. Now we got these differences. So let's, if you remember at the previous unit hydrograph for 3 at the previous calculations, I multiplied with the ratio. So now again, I'm going to multiply with the ratio. So which one is given? The 2 hours unit hydrograph. Which one is asked? 6 hours. So I am going to multiply this all measurements one by one with 2 over 6. Okay, this is unit hydrograph for 6 hours. So let's do it. And for this one, 3 might multiply 2, 6 over 2, 1. Okay, this is 0, this is 1. 12 multiply 2, 24, and over 6 is 4. Okay, so it's going to be something like that. Let's write it here, just 1. 30 multiply 2 over 3, sorry, over 6. This is going to be 60 over 6 is 10, right? So 10, 15, 19, 22, 23, 21, 15, and this is going to be 10, 6, 3, 1, and 0. Now we also obtained the unit hydrograph for 6 hours. Okay, so now let's take the summation of them. We are going to apply this formulation. Okay, look at here, this formulation. 3 hours unit hydrograph for 3 multiplied unit hydrograph for 6 hours plus 9 hour lagged 3 multiplied unit hydrograph for 3 hours. So this is going to be something like that. Look at here. This is 6 hours. Okay, 6 hours unit hydrograph. So now we write it until the down and this 14th column, and I told you that it's going to be 9 hour, okay, 9 hour lagged unit hydrograph for 3 hours. Okay, I got the unit hydrograph. If you remember, at the first I calculated that. So now I'm going to lag it 9 hours. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you can see 9 hours I lagged it. So after that, I'm going to start with the 0 and then until the last column that has to be written. Okay. So now let's take the summation of them, because if you remember the formulation, one second, I'm going to take the formulation down for you. Both three are common, okay? So I'm going to take them into parentheses, okay? Take them into parentheses, and then I'm going to multiply 3. Look at here. I'm going to take the summation of them, then I'm going to multiply with 3, and I'm going to obtain the SH. So now let's do it. This is going to be 0, 1, 4, 10, 15, 19, 22, 23, and 21, and it's going to be 15, 12, 14, 23, and 29, and this is 30, and this is 24, and this is 18, this is 12, this is 6, this is 2, this is 0. Okay, this is all 0. But I don't need to write, I guess you understand. Okay, so now we got it. So let's multiply with 3. If you remember, I told you that I'm going to take into parentheses. Okay, so let's multiply with 3. 0 and 3, 12, 30, and this is going to be 45. This is going to be 57. This is going to be 66. This is going to be 69, 63, 45, 42, and sorry, no, made a mistake. Yeah, 36, 42, and this is going to be again 69, 87, 90, and this is going to be 72, 54, 36, 18, 6, and 0. Now we got all measurements for SH, okay, for this equation. This is the hydrograph of this equation. So now, if you remember that in the question it says that ordinates of the storm hydrograph assuming a constant base flow of 10 meter cubic per second. So now it asks to add the 10 meter cubic per second as a constant base flow. So the water normally in that river. So now we are going to add it. This is going to be 10, 13, 12, 22, 40, 55, 67, 76, and 79, and 73, 55, 46, and this is going to be 52, 79, and 97, and 100, and 82, and 64, and 46, 28, 16, and also 10. Okay, now we got it. This one this is the hydrograph of storm. This one for the result of C. And if you remember for part D, it says that area of basin. So how we are going to calculate? We are going to take the summation of SH, okay, the summation of SH without the constant base flow, okay, without constant base flow. Don't forget it. So when I take the summation of these measurements, these discharges, I am going to obtain the total discharge is equal to 900 meter cubic per second. Okay, the summation of this whole is going to give you this amount. So now I have it. So let's calculate the volume. Okay, I have to convert this discharge to volume. Okay, so volume 900 multiplied 60 seconds for 1 minute, and for 1 hour is 60 minutes. 324,000 meter cubic. Now this is the volume of the water. So let's write a formula. If you remember, volume is equal to area multiplied the depth of water, okay, the depth of surface runoff. So now this is going to be, but due to unit hydrograph, this is unit hydrograph. So this is going to be 324 equal to area multiplied H. So what is H? Let's check what is H. H is here. Look at here. I'm going to show you. Yeah, I can show you here. This is a unit hydrograph, right? A unit hydrograph. Look at here. And we have a 3. So this is 1 centimeter, and multiplied 3 is 3 centimeter. Okay? And this is 1 centimeter. When I multiply 3, it's going to be 3 centimeter. So 3 centimeter and 3 centimeter, it's going to be 6 centimeter. When I convert it to meter, 0.06 meter, right? And now I'm going to write into H is 0.06. Okay? When I write into H is 0.06, and I'm going to obtain the area 54 million as a million as meter square. Okay, when I convert it to the kilometer square, it's going to be 54 kilometer square as the area of the basin. I wish you understand how we are going to obtain the storm hydrograph and also determine the area of that basin that rainfall happened. So now the question is solved. See you for the next question.